My name is Jonah Meyerberg. I'm a co-founder and CTO of Desktop Metal. And what we've done is we've developed and launched here a 3D printer for metal that is safe and capable of printing metal parts in your office. Now, a lot of the state-of-the-art metal 3D printers use a powder bed fusion technique. Problem with powder bed is that it's messy, it's unsafe, and sometimes you have to suit up completely to operate with the machine and with the powder. We wanted to get away from that. It's expensive, it's dangerous, it's not as accessible to everyone as, say, FDM printing. So we took a very similar approach to an extrusion technique to bind the powder into a polymer matrix, extrude it, and then consolidate it in a furnace. Everybody knows FDM printing, understands the techniques and limitations that that process has, and it's very easy to operate. We've designed the software from the ground up. We've started with the slicer and the technique that's used to print the part, to support the part layer by layer. We're telling the part, the operator the best way to build that part. That is then transferred through the cloud to the furnace. The furnace knows exactly what has been printed and therefore knows the profile at which it needs to sinter the object at. That creates a solid part when you print it. Once you take it out of the furnace, the part can lift right off of its supports. So this is a step towards direct manufacturing. We're talking about a prototyping process here where you can develop a functional part with the same materials that you're going to use in mass production. And then we've launched the production machine that you can then take those same materials and launch into mass production. Printing process is going to be competitive with high volume manufacturing processes like metal injection molding, for instance. The Desktop Metal production system is 100 times faster, and it's designed to compete with the high volume manufacturing processes that are commonly used in consumer electronics or in the automotive industry. It's designed to be a mass production build box. So in other words, printing hundreds of parts nested on top of one another. Not hundreds of print beds, but layers, so multiple layers with multiple parts on each layer, separated on top of each other. And then when you take the parts out of the printer, you put them into the furnace in the same kind of way, on layers of kiln furniture, and then the parts are consolidated. Very similar to the way that metal injection molding is done, with the same materials as metal injection molding. So if you're a customer and you want to become more flexible in your designs, you want to use additive manufacturing, you don't have to change your alloys, you don't have to change your systems. You're using 316 or 17.4 stainless now, you can use that exact same material in our printers.